Hey guys, hope all are fine. So today we will see the working of Mosfet. Okay. So first let us draw the symbol. So this is the Mosfet symbol. So this is your gate, this is your drain, and this is your source. Okay. So this is the symbol. So today we have taken IRF 540N Mosfet. So this is nothing but an N channel Mosfet. Okay. So first let me explain the working. See, very simple. Whenever the gate voltage is greater than 2 volt, which means the minimum voltage required to turn on this MOSFET is between 2 and 4 voltage. So whenever you give any voltage between 2 and 4, but this voltage varies from company to company, okay, manufacturer to manufacturer. So but the minimum voltage to turn on an MOSFET is 2 volt. Maximum voltage is 4 volt, which means any voltage between 2 and 4, your MOSFET will turn on. So the moment your MOSFET is turned on, the path between your drain and source will be activated, which means the current will start flowing from your drain to your source. Okay. So this is the basic working principle of a MOSFET. Is that clear, guys? Now with this working, we will see a basic circuit, that is to switch on an LED with this MOSFET, at the same time to control the brightness of the LED also. Okay. So I'll tell you how to control the brightness with this MOSFET, because this MOSFET, what happens as you keep on increase the voltage at the gate. See, to turn on the MOSFET, it is enough if you give to a voltage between 2 and 4 volt, but you still keep on increase the MOSFET gate voltage, the current between drain and source can be controlled. So the higher the voltage, gate voltage, the higher the current flowing from drain to source. So that current can be controlled. With that, we are going to control the brightness of an LED. Okay, so that is what we are going to see. So first we will see the circuit and then we will get into our practical. Okay. So first to draw the circuit. Okay, this is the drain, your MOSFET. So to the drain I'm giving an 8 volt adapter. This is from adapter. Okay, so this is an 8 volt 0.5 amps adapter, and in the drain, so this is your drain, this is your source, and this is your gate. Okay, so drain we have given supply, to the source we are connecting an LED. Okay, this is our LED. So this is 1K. This 1K is to resist the current flow to your LED and connect it to the ground. Okay. Now, as I already told you, whenever you give a gate voltage, your path between drain and source will be established, right? So we have to give some voltage to the gate. So that voltage we will directly give it from this 8 volt itself. So to give, so it is enough if we give only less voltage, right? So to control the voltage, we will connect a potentiometer here. Okay, so that if you turn this potentiometer, we can make sure that exactly any voltage between 2 and 4, that is between this 2 and 4 volt required to turn on the MOSFET is applied. So this is the circuit. Now what happens, you turn on this potentiometer, whenever you rotate this potentiometer and whenever this gate is having 2 volt, this MOSFET will be turned on. Whenever the MOSFET is turned on, the current from this 8 volt will be flowing through the drain and source, and it will flow through the LED and LED will glow. Okay, now to control the intensity of this LED, what we are going to do, we are again going to increase the voltage to the gate. When you increase the voltage to the gate, the current flowing from the drain to source will increase, so that the current flowing through the LED will increase and the brightness will increase. Okay, so this is what we are going to see in the practical also. Okay, so always remember, with the help of a gate, MOSFET, by varying the gate voltage, you can control the output load. So you can connect a motor here. By controlling the gate voltage, you can control the speed of the motor. Okay, so here I have connected an LED to change the brightness. You can connect a motor and you can control the RPM. So whenever you increase the voltage, current flowing through the gate will, from drain to source will increase. So the motor RPM varies. Okay, okay, guys, we will start our practical. So we have all our component, we have multimeter to check the voltage, we have a trim pot to vary the resistance, and this is our MOSFET. Okay, So here this is our IRF 540 MOSFET. Here the MOSFET, the pin diagram will be gate, drain and source. Okay, the left hand side will be gate, the center pin will be drain and the last pin will be source. Okay, so to the gate we will give voltage, to the drain we will give the supply voltage, and from the source we will connect our load. Okay, and all the other things we have an LED to as our load and connecting pins. Okay, so first we will connect our, this is our adapter which we will have 8 volt and 0.5 amps. Okay, so connect your adapter positive and negative. So this is your trim part. Okay, so usually this trim part will will vary the resistance so that we can vary the supply. Okay, so from positive I am connecting it to one of the pin, that is the leftmost pin. From the center pin, see, when we vary the resistance, the output at the center pin vary. Okay, so you connect the rightmost pin to the ground. So leftmost pin to the supply, rightmost pin to the ground, so that the output will be in the center pin. Okay, so connect your MOSFET here. So now from the center pin you take the output. Okay, take the output from the center pin. Fine. Now this output, okay, will be supplying it to our gate. See, now whenever this potentiometer, that is this trim part, is varied, the voltage at the gate will vary. Okay, and for the drain you have to give the supply. So I am directly giving the drain supply from our positive, which means I am directly giving the 8 volt to our drain. Okay, you can give any voltage to a drain. This MOSFET particularly is having nearly 100 volt. Okay, so you can give any voltage depending upon the load. Okay, before using any component you have to make sure that you read the data sheet. Okay, so from the source I am connecting an LED, I mean resistor, as you have seen in the circuit, to reduce the current flow to our LED, and I am connecting the LED to the ground. Okay, so now you can see the LED is not glowing. Okay, so this is because the voltage at the gate side will be lesser. Okay, we will check the gate voltage now. We will see what is the gate voltage. So this is the gate pin and this is the negative pin. See, the gate voltage is 0 now. Okay, we did not give any. See, this is the gate and this is the voltage which you can see in the multimeter, it is 0. So we did not give any gate voltage. So slowly we will increase the gate voltage by increasing the potentiometer. Okay, so slowly I have increased to some extent. Now we will see what is the gate voltage. So it is only 0.87. So we have to give between 2 volt, right? So again increase the, so now check the gate voltage. See, now it is almost 5 volt. See, now you can see the LED is turned on. So which means we have given enough voltage to the gate so that the LED is turned on. Now it is acting as a switch, which means the transistor, I mean MOSFET is on and the LED is on. Now again, as we discussed in the circuit, to control the intensity of this LED, we have to again keep on increasing the current flowing from drain to source. See, as you increase the voltage, gate voltage, the intensity is increasing, as you can see. Can you see this, guys? See, I am turning it. See, now it is decreasing. It is switched off now. See, now slowly I am increasing the resistance. So the gate voltage increases and the intensity of the LED increases. Okay. So this is how MOSFET is used to control the output. That is the load. Okay. So if you connect a motor here, it will vary the RPM of the motor. Okay guys, so this is how a MOSFET works.